The guitar. Historical background. The guitar has its origins in antiquity more than 3,000 years ago in Egypt. The guitar appears in many centuries, many countries of Europe. However, it basically developed in Spain. By the end of the 13th century, Spaniards made it a developing art. The Spanish school of guitar making was established in the late 19th century. In the 20th century, guitar has become one of the most popular instruments in the world. The guitar has evolved from a simple 17th century six-string instruments to a modern electronic tool used nearly in all types of music. In the US, there are estimated anywhere between 15 and 20 million guitars. So how is it constructed? The top is usually made out of spruce, panned to a thickness about 2.5 millimeters. The back is usually made out of hardwood such as rosewood, mahogany, or maple, also about 2.5 millimeter thick. Both top and bottom are braced. The braces strengthen the fragile plate and also transmit vibrations of the bridge to various parts of the soundboard. Deconstructing the guitar. This is what the different parts of the guitar would look like. The top half, the bottom half, the ribs, the tail block, and so on. And now let's look at the different components of a guitar. So that's the body, the back. So how does the top plate vibrate? The strings couple to the top plate. Guitar bracing influences the top vibrations. So as you pluck the string, the string will set up a sympathetic vibration into the top part of the guitar, which in fact basically will transmit that into the body of the guitar as also to the back plate. And so through sympathetic coupling, the sound will resonate inside the guitar and will come out of the sound hole. Bracing of acoustical guitars are of different kinds depending on what culture, what country, what type of music you are talking about. The bracings are placed at strategic points where the nodes of the guitar are placed. Anywhere else it would destroy the sound. Family of acoustical guitars include classical, flat top, arch top, and so on. Again, different guitars use different kinds of strings, and all of those different kinds of strings produce a variety of sounds. Here is a picture of the anatomy of a steel string acoustical guitar. If you want to look at the details, you should go read the book. So this is what we were talking about, the guitar as a system of coupled oscillators. So when the string vibrates, the bridge and the top plate vibrate. The top plate vibrates more for higher frequencies, and the resonance is set up for the top plate. For the lower frequency, actually the top plate goes into vibration. The air cavity and the ribs are the ones that couple together with the sound hole and the back of the guitar to produce the lower frequencies. So basically the lower frequency sounds are generated by the top and back plates and the sound hole. The higher frequency, most of the sound is radiated by the top plate. Here is a very, very good example of what you should try to do yourself. Find the frequency and the wavelength for a 1 liter bottle given A equals 3 square centimeters and L equals 5 centimeters. So we have a formula. If we wanted to find the frequency and the wavelength of this, we will have a formula which is Fn equals V over 2 pi square root A over VL, where A is the area, L is the length, and V is the volume. So in this question, they ask us to find the frequency given the wavelength. It gives us that the volume is 1 liter. It gives us area, which is 3 centimeters squared, and it gives us length, which is 5 centimeters. Now, there is a problem with every single one of these units, right? They're not SI units. So the first thing we need to do is we need to convert them to SI units. Now, how will we do that? Well, 1 liter is equals to 0.001 meter cubed. Okay? Area is centimeters squared. So how do we convert centimeters? So this is going to be 3 centimeters. That's what centimeter cube means. Now in order to convert it, I have to do 1 over 100 centimeters times meters divided by 1 over 100 centimeters divided by meters. Okay? So now this centimeter goes away. What do I get? I get 3 times 1 over 100 times 1 over 100 meters squared. So in fact, the area now will be given as 0.0003 meters squared. You guys should plug this into your calculators and try to figure out the correct answer. Now for your length, this is 5 centimeters, right? So how do I convert 5 centimeters? This is going to be 5 centimeters times 1 over 100 centimeters meter, right? Centimeters go away, and we get 0.05 meter. So once you've done that, then all that's left is for you to be plugging in these numbers into your equation that's given over there. So for example, this V, we know that this is going to be equals to speed of sound divided by 2 pi square root of A over VL. Right? What is the speed of sound? It's 343. Assuming that we're talking about the condition in room temperature, we will have 343 divided by 2 pi square root. A, we calculated it to be 0.0003, right, divided by V, we calculate this to be 0.01 meter cubed, right? And then we calculated L to be 5, so this is going to be 0.05 meter. And when you calculate all of this out, you will find that this, the value of your frequency is going to be 134 hertz, because the units of frequency are hertz. The electrical guitar is a modern invention. So even though it is possible to attach a contact microphone to the body of an acoustical guitar, however, when we do that, it introduces unwanted harmonics. An electrical guitar uses magnetic pickups in which the vibrating strings introduce electrical signals directly. Electrical guitars may have a solid wood body or a hollow body. Vibrations of the body have much less influence on the tone in the electrical guitar than in acoustical guitar. Solid guitar body is heavier and less susceptible to acoustical feedback from a loudspeaker to the guitar, and it allows the strings to continue to vibrate for a slightly longer time. So now let's compare acoustical guitar sound to an electrical guitar sound. So we will start with the acoustical guitar sound first. And next, we will look at the electrical guitar. Other bowed string instruments include viola, cello, string bass, and so on and so forth. The general shape and construction of the viola and the cello are similar to that of the violin.